Okay, let's do a quick review of friction. It's been a minute or so. So we're pushing a car. What type of friction is pushing a car? You should be thinking wheels on the car, so that would be rolling friction. What about leaning against a wall? Remember, we're not going to get that wall to move. This is the only one that has a balanced force. It's static. Third one, skydiver falling. Again, they're falling through the air, and the air is a gas, so this is going to be fluid or liquid friction. And the last one, pushing a desk. We've got two surfaces moving past one another. That one is called sliding. Okay, so we've got one more topic today, and that is gravity. Now, we all know that gravity holds us to the earth, and in science terms, it's an attractive force between any two objects that have mass. So the earth has gravity. It's a really big object, and so we can feel that gravity. The sun has gravity. It's even bigger. That's what's holding us in our orbit. But you have gravity as well. Any object. So really the things around you are attracted to you. But your gravity is so small that we can't actually feel that. So we can say that the relationship is the more mass you have, the more gravity you have. The big sun has more gravity than the earth. The moon has less gravity than earth because it's smaller. You also can feel gravity more if you're closer together. Okay, so the closer you are to something, the more gravity you're going to have as well. Now, gravity, again, accelerates us towards Earth. It holds us onto Earth. And that acceleration is at 9.8 meters per second squared. Just like we saw in our force lab that we did earlier in the week, anything that's hanging towards the earth, like we were hanging those objects on our spring scale, are going to cause a gravity of 9.8 meters per second squared towards Earth's sentence. Now, the problem here is in a perfect world, it would always be an acceleration of 9.8 anytime anything fell. But there's always going to be air resistance acting because there's air all around us. And air resistance is a type of friction. It acts in the opposite direction of the object, and that's going to be a fluid friction. So really, when you're falling, let's say you fall out of a tree, you're not going to be accelerating at 9.8 meters per second squared because air resistance, that fluid friction, is pushing back up. Now, if you fall for a long enough period of time, you're going to hit something called a terminal velocity. And you guys put this in shorter words. This is a long sentence. Terminal velocity is when the force of gravity is equal to the force of air resistance. So the forces are balanced and the object cannot go any faster. Okay, so the force pushing us down, that gravity that's pushing us down, is equal to the air resistance pushing back up. And we're not going to go any faster. Our forces are balanced. Now, that doesn't mean that we're going to stop in midair. Remember, it just means that we're not going to change our velocity. Okay? So we're still moving. We're just not speeding up anymore. So again, it's really important. The object is still moving. Go ahead and draw a stick figure with its arrows pointing up and down in your notes. And that's the basics of gravity.